put the input as logic 1. This input will be shifted, okay, to the flip-flop. On another time, let's say T2, we still put the input as 1. This input now being shifted to the right. At 3T3, we shifted another 1, and after the fourth cycle, all the input has been shifted, something like that. So we can see the input state has been shifted. So this is the shift register. So the situation is accomplished or can be implemented using this arrangement. We have 4 flip-flop, 4D flip-flop, D2, Q2, Q2 bar, Q3 bar, and then D1, Q1, Q1 bar, and finally D0, Q0, Q0 bar. And the clock are connected together because they are synchronized. Because they are synchronized like that. So the Q3 is connected to the next like that. So you can have the input Q1, Q0, Q1, Q2, and Q3. So the clock is like that on every positive edge triggered. And we put here always logic 1. So we shift this value to the right. We call it shift register. So we cascade the the flip-flops, and we can have the register and also the counters. Registers, and as we have seen before, have a
Doctor, please, can you go up a bit?
Sorry?
Can you go up? Yeah.
Where were you just now? You just coming in?
No, I was using my phone before, so I switched to laptop.
Never use handphone.
I was at the toilet, so I had to use it. I'm sorry, doctor.
Done,
Yes, I'm done.
We can say this is a regular shape, or regular structure. We have a regular structure that allows the circuit, registers, and counters to be designed using an intuitive approach. Just now, when I draw the register circuit, we just connect the something like that in a regular shape. We can have a shift register. But we have a formal or step-by-step design approach. Or sometimes we call it design procedures of sequential circuit. Okay, we have a general step by step. So number one, we need to know the functional description or specification. Okay, so before you want to draw, you want to design some system, any system, so there you must have a specification what you want to design, or that could comes from your manager or your boss where you are working with. They give you some specification. Okay, so once you have the specification, you have to translate it into state diagram, and then the state table.
Sorry, doctor. For the first one is functional
Description.
Okay, thank you, doctor.
Description. And then maybe we need to do the state reduction. Okay, some from the table, from the state table, we may some of the state could be redundant, so we can do the state reduction. And then we call it state code allocation, or sometimes we call it state assignment. So what is that? And then finally, circuit implementation. Okay, so we complete the design step. Nurul, mana Nalan?
Dia tak masuk, doktor?
Ada?
Tak ada. Saya mesej dia.
Dia dah datang kot, doktor. Sebab besok Deepavali.
I know. The Deepavali is tomorrow, not today.
Dia orang nak buat preparation kot.
Yeah, I know. But you can skip the preparation for 50 minutes. You don't have to come to UPM, right?
Yeah, doctor.
Okay, so let's look one by one. The step one, the functional description or specification, and this could be done in either in written form, okay, or in diagrammatic form. Okay, engineers normally like to use the diagrammatic form. Okay, so one method of diagrammatic form approach is by using arithmetic state machine. Okay, arithmetic state machine. Okay, is ASM is shown or done using flow chart like notation. Okay, remember flow chart, to make a description, you use triangle. To make a decision, you use the diamond. For start and stop, we use oval, and another one is circle. What is the circle for? Okay, so
Input.
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 Oval is input. Now,
Oval.
step 2 is state diagram. And this is used to translate the written specification into a systematic diagram. And the diagram, there are two formal representation for diagram, for the diagram. Of state diagram. Number one is using what we call it a Mealy model, and the other one is Moore model. Okay. So for the Mealy model, we use, we call it a node, and the node has the name. There are two nodes here. So nodes, okay, this is node. The nodes contain state label, okay, the label, L-A-B-E-L, label only, okay. And then that is the node. Example, node A and node B, the node has got the name. The state label, the label of the state is A and B. And then there is a path, okay, we call it path. It has got variable of input and variable of output. So the path are labeled with input and output variable. Okay, so the path may also coming back depending on what is the condition of input and output. So this path, when coming back, is called a sling. Okay. Input variable or input and output condition. Variables, input and output variables. So this is also path, but the path, when it is coming back to the same node, we call it a sling. Whereas the Moore model, nodes, the nodes contain state label and output condition. Okay, the path are labeled with input condition only. So how? So when we have node A, we have the output condition, that is the node. Node B, that is the output condition, that is the node. And then the path, we got input condition, the input condition, input, okay, like that. What is the condition of the input? Whether it will sling or go back to B. So the output condition is written here inside the node. So how do we use this? For example,
Doctor, could you please show the previous one? Thank you, Doctor.
Okay. For example, for
Doctor, please, can I see the previous slide? Just a moment. Okay, doctor.
JK flip-flop. We have the input. What is the input of the JK? Flip-flop J and K, right? And the output is Q. Okay. So we can have a two condition A and B. Okay. From the condition A, when it is 0, 0, it will remain at A and the output is 0. Or when the input is J1, J0, K1, the output will be 0. Okay. But when the input is 1, 0 from the condition A, the output 0, it will goes to the next. If it is 1, also will give the output 1, which is the next state. From this state B with the output 1, okay, when we put the input JK00, the output will remain 1. If it is 1, 0, it will remain 1. Only when we put 0, 1, the output will go to 0, or 1, 1, the output will go to 0, meaning that is the second condition. Remember the JK, QN, and QN plus 1. When if the condition of previous Q, in the previous Q is 0, meaning in A, when the JK is 0, 0, the next will be 0. If it is 1, 0, 0,
One.
it will remain at 1. For 0, 1, when the input is 0, the output next output will be 0. It is 1, 1. 0, 1, when it is 1, it will go to 0. 1, 0, 0 is 1, 1 goes to 1, 0, when it is 1, 1 goes to 1, when it is 1, 1, 1 goes to 0. Correct? Is it same with your notes previously?
Yes, doctor.
Yes, doctor.
Okay. Okay. So in this case, A and B is the name of the state inside the node. We put inside the node. So what model is this?
Mealy.
Mealy model. Can you do for the Moore model? Okay, can you do that? A with the output, B with the output 1. So it will remain at A when it is 0, 0 or 0, 1. It will go to the next state if the input is 1, 1 or 1, 0. And it will remain in this B when it is 0, 0 or 1, 0. And go to the next state, to the other state when it is 0, 1 and 1, 1. Okay, so this is Moore model. So this path is called the sling. This is sling. So sling is the path direction when initial state and final state are the same. Okay, that is the state diagram. So step 3 is
Sorry, doctor. Can you go to the previous slide? The other one, the states diagram.
okay. So finish.
The Mealy states diagram, the other one, the upper one. Okay, doctor.
The next step is the state table. So state table is to be used for defining state table from the information of state diagram. Okay. For example, just now we have the last one, AO, B1, 1011, the JK and Q, input and the output, JK and Q. So when it is 0, 0 and 1, 0, go back to 0, 1 and 1, 1, and sling when it is 0, 0 and 0, 1. So we can make a state table. There are 3 sections: the present state, the next state and the output. Okay. Depending on what is the condition of JK, either 0, 0, 0, 1, 1, 1, or 1, 0, depending on the input JK of 0, 0, 0, 1, 1, 1, or 1, 0, from the state A, okay, when the JK is 0, 0, it will remain at A. And what is the output? 0.
Oh.
When it is 0, 1, it will remain at A and the output is 0. When it is 1, 1, goes to B, or 1, 0 goes to B, the output would be 1. From state B, if it is 0, 0, it will remain at B, the output is 1. 0, 1 goes to A, the output is 0. 1, 1, it goes to A, the output is 0. When it is 1, 0, remain at B, and the output remains still the 1. Okay, so that is the state table. Everybody follow?
Yes, doctor.
Follow.
Shazana, awak boleh ikut tak? Shazana, Akila. Ella, do you follow Ella?
Yes, doctor.
Okay, good. So you are celebrating Deepavali tomorrow, right?
Yeah, I'm going to Melaka today.
Going to
Melaka today.
Mecca,
Melaka.
Melaka. I thought you want to go to Mecca. So how are you going there? Drive?
Yeah, I'm going to drive.
Yeah.
Doctor.
Careful. The traffic might be heavy, eh?
Okay, doctor. Thank you.
Okay. From
Sorry, doctor.
this, yeah.
I have a question. For the next state and the output, it should be written in 0, 0, 0, 1, 1, 1, and 1, 0, or it can be 0, 0, 0, 1, 1, 0, and 1, 1.
Yeah, okay. Because I normally want to follow this. 0, 0, 0, 1, 1, 0, and 1, 1. But if you have 4 like that, it's okay to use which one? 0, 1. No, we will use 0, 0, 0, 1, 1, 1, 1, 0. So I conveniently follow this notation of the Karnaugh map. But it is okay to use. Important is what is the condition and what would be the state. So in this case, A and B represent the internal state of the JK flip-flop. Okay. But in digital system in general, we only use 0 and 1, correct, as variable. Okay. So in this case, we may represent the variable a with 0, a as 0 and b as 1. So the table with 0 and 1, the table with 0 and 1 code assignment become, okay, you have present state, the next state, and the output depending on the JK, either 0, 0, 0, 1, 1, 1, or 1, 0. The condition for JK either 0, 0, 0, 1, 1, 1, or 1, 0. So we have two states here, 0 and 1. And we change A with 0 and B with 1. The output remain the same. So if it is from B, we change to 1. It became 1, 0, 0, 1, 1, 0, 0, 1. Okay. So we set this, the one with like this is called the state code alignment, code assignment, code allocation, or code assignment. We have assigned the A and B into binary code, okay?
Sorry, Doctor, could you show the last one, the diagram? Thank you, Doctor.
Yeah. So if we can reduce the state, if we reduce the state, then we can do the reduction, but not in this example. Look at this, another example. What example is this? Example number 3, is it? Or 2? So let's say we have a system with input and output represented by the input is X, the output is Z, okay? It is described by the state diagram as 0 with output 0, the node number 1, the node number, number 1, the output also 0. And finally, the node number 2 with output 1. Okay, there are 3 nodes, 3 states. When X is equivalent to 1, it will go to node 1. If the X is 0, it will sling. From node 1, if X is 0, it will goes back to state 0. If x is equivalent to 1, it will go to state 2. From state 2, if x is 0, it will go to state 0. If x is equivalent to 1, there is a sling, meaning to say remain at state 2. Okay. We can also use 0 as A, 1 as B, and 2 as state C, and 2 as C, like that. So you have probably that is A0, B0, and C1, like that. What is the name? The model?
Moro. Moro.
Of the state diagram. So your answer is Moore model. Moore model. Okay. The Moore model. So correct, Okay, can you redraw the diagram using the other model? What is the other model?
Mealy.
Mealy model, okay? Can you redraw it? So you have 0, 1, and 2, right? So if x is 0, the output is 0. If x is 1, the output is 0. From 1, when x is 0, the output is 0. When x is 1, the output is 1. When x is 0, the output is 0. When x is 1, the output is 1. Everybody got the same?
Yes, Doctor.
Eliani Sofia, awak dapat yang sama dengan diagram saya?
Ya, Doktor.
Awak buat sendiri? Salin saya punya lah.
Ya, salah Doktor.
Okay. Can you find the state diagram and the state table? You find the state table? Masa dah habis
Dah habis.
Nurul, do we still have time?
Sekarang pukul 12:02 tu.
Oh, dah habis lah kot. Okay, you stop here. You do it as homework, the state table. Nanti awak tunjuk dekat